Hello, everybody. This is Paul again. And now in this tutorial, we are going to take a look at creating a mission profile again, but instead of hard coding all the values like we did in the previous tutorial, this time we're going to make it parametric. So we reviewed a hard coded mission profile just so you could get a feel for what the inputs looked like. But now what we're going to do is show you one in which you can use the mission profile on multiple aircraft. And that's the beauty of making these parametric. So what we're going to do is we're actually going to take some information from the aircraft structure such that we don't always have to prescribe a hard-coded range or cruise speed or cruise altitude. We can use that information from the aircraft structure instead. Also, if you remember from the last video, there were a lot of numbers that we were repeating, especially because you have to prescribe the beginning and ending segment altitudes and velocities. So you saw a lot of repeat numbers. Now what we can do is we can just set those to a variable instead, and that'll make our implementation or description of the mission profile much, much, much cleaner. So let's go take a look at MATLAB now. So the mission profile that I'm going to show off today is called Parametric Regional, very fitting for our tutorial on parametric mission profiles. And in case you're wondering where this mission profile is, it is with all of the mission profiles in FAST, and we store those in the mission profiles package. Pop it open, and you'll see Parametric Regional is right here. In the last video, when we were looking at the hard-coded mission profiles, we went through this README. As a reminder, make sure to check out the README before you create any mission profiles. In addition to a written tutorial, it has some helpful tips. So just like we saw in the last video with the mission profile, we have one input and one output. Those are both the aircraft structure. And the reason we do that is, one, to append the mission profile to the aircraft structure, but also in this video, we can now use information from the aircraft structure to customize our mission profile and make it parametric for all the different aircraft that we want to fly it on. So for example, in the last video, I had a 2,150 nautical mile range. But what if I have a family of aircraft where one of the design ranges is the 2,150 nautical miles, but some of the others, it's like 1,650 or 1,800 nautical miles, right? It would be a pain to have to change this mission profile over and over just to accommodate that family of aircraft. So what this allows us to do by making it parametric is I can use multiple aircraft on a single mission, and that's great. So similar to every function in FAST, we have the same header. As a reminder, function call, who wrote it, when it was written, a description of the function. And again, you know me, I like my ASCII art, especially when I'm describing my mission profiles, along with a list of inputs and outputs, which we already talked about. It's just going to be the aircraft structure. I'm going to skip over this first section here, which is importing all the performance parameters from the aircraft structure. We'll talk about that in a little bit. What I want to do first is spend some time defining the mission targets and reviewing the segments, and then we'll see the variables that we need to call, and then return to that top part of the code to see what they represent. So similar to the last one, we're going to have two targets. We're going to have a design range and a 45-minute loiter. So the second target is still time-based, and we're going to keep that hard-coded because regardless of the aircraft I'm flying, I want that 45-minute loiter. It's not going to change. But the design range will. So you can see that instead of prescribing a fixed number, I now have the variable range instead. And you'll notice if we actually scroll back up to the mission profile, you'll see it looks fairly similar to the previous one we had, where you have takeoff, climb, cruise, descent, landing. But what we're actually going to do in this mission profile is make the climb and descent segments a little more granular. So instead of having just one climb and just one descent, we're going to have multiple to make it a little more realistic to how airplanes actually fly. And the more realistic your mission profile is, the more accurate your block fuel or energy required or battery required will be in the mission analysis. So defining a simple mission profile like we saw in the previous video is great for just getting things started. But when you're really trying to model an aircraft in detail, not only do you want to provide as many specifications as you can, but you really also want to provide a lot of detail for the mission profile, because this will greatly impact the fuel burned or the energy consumed. So you'll notice here, instead of having just one climb segment, I actually have 3 climb segments. And so how I define these is I have one going from takeoff to some intermediate climb altitude, another one from that climb altitude to more of like a transition altitude that we'll call climb to cruise, and then from climb to cruise up to my cruise altitude. And we'll do a similar thing on the 3 descents. I'll go from that cruise to this transition, from the transition down to the final climb altitude or the lower climb altitude. And then for my reserve, instead of hard coding anything, I'll specify it as a reserve or a res altitude beginning. And I'll do a similar thing in the reserve mission. I'll have a couple different climb segments. I'll cruise. I'll have a few different descent segments, and then I'll land. And you can see a similar nomenclature in defining the velocities. So at takeoff, I'm accelerating to my takeoff speed. I'm going to climb. I'm going to accelerate to my climb speed in the first climb segment. I'm going to climb at that climb speed in the second segment. And then in the third climb segment, I'm going to accelerate from my climb speed to my cruise speed. So you can see it's a little more granular, because in the previous one, we were just gradually accelerating from takeoff speed to our cruise speed, and we were only using one segment. But now we're making it a little more granular, because we're going to climb a little bit and accelerate. Then we're going to do a lot of climbing without much acceleration. And then once we reach our cruise altitude or something very close to it, we'll begin accelerating again. And this is what airliners do when they're flying during a day of operations. So this makes the mission profile much more realistic, as I was talking about a little while ago. And you'll see the similar nomenclature, takeoff speed, climb speed, cruise speed, descent speed, approach speed. And then when we get off into the reserve missions, those all start with the res. So res vel climb for the reserve airspeed during climb. Similar thing for cruise and descent. And then again, we come in with our approach speed and stop. Another great thing about the parametric mission profile is that it uses all 3 speed types. So when we're taking off, we're flying, we're referring to the velocities as their true airspeed. But then when we climb, aircraft actually usually climb at a constant equivalent airspeed. So you can see we start at our takeoff speed, which is in a true airspeed, and then we accelerate to our climb speed, which is now an equivalent airspeed, and FAST will do those conversions internally for you. Then we're going to climb at a constant equivalent airspeed, which actually means you're climbing at an increased true airspeed, but I digress. And then you accelerate from that equivalent airspeed to your cruise Mach number. So this one's a little bit more realistic to what's going on in an actual aircraft. And you'll notice for all of these climb segments and descent segments, I'm going to leave the climb rate as not a number, and I'm just going to let FAST compute it internally and figure it out. And remember, after you define your mission profile, make sure to store it in aircraft.mission.profile. Otherwise, FAST won't know what mission to fly. So now that we've gotten used to the nomenclature a little bit, let's go back up to the beginning of the MATLAB script and see what all of these values mean. Which ones are we just setting as variables that we can change in the mission profile, and which ones are we actually getting from the aircraft structure? So if we look up here to the import the performance parameters section, it looks like I am getting the mission range which was one of the targets we prescribed earlier, as well as the takeoff and cruise altitudes from my aircraft structure. Then you can see what's going on is I'm converting all of my intermediate altitudes for both the design and reserve mission from feet to meters, because FAST requires all of the inputs to be in metric units. And then you can also see that we are importing the takeoff and cruise speeds from the aircraft structure. And it's really important to note that the takeoff speed in the aircraft structure is provided as a true airspeed, but the cruise speed is specified as a Mach number. So be careful that when you are creating your mission profiles, there could be a case where you accidentally put it in as a true airspeed or vice versa. So just be careful with that. It's also covered in the documentation, but again, we just want you to make a note of it. And then we also define some intermediate speeds, like the approach speed, which we assume to be 20% faster than takeoff, as well as some of the climb and descent speeds. We hard-coded a number, but we at least set it equal to a variable such that it's easier to change the mission profile specification down here. So I don't have to go in and change numbers every single time. I can just change it in one spot. So you can already see the advantages of having a parametric mission profile. Not only can you take things in from your aircraft structure, it's a lot easier to define once you actually get going with making these really complex or more detailed mission profiles. And so with that will wrap up this video. We hope this was a little insightful as to how you can create more detailed and parametric mission profiles. And if you've reached this tutorial, that means you know enough to use FAST on your own now. We've already covered the aircraft specifications. We've already covered hard-coded and parametric mission profiles. So now you're all set to go forward and make your own aircraft and your own mission profiles. So we'd like to thank you for watching this video. And in the next ones, we'll start talking about the propulsion architectures. So we've taken care of the inputs we need to main, the aircraft specification file, and the mission profile specification. Now what we're going to do is look at different propulsion architectures. So what if you don't want to use any of the 6 that we provide in FAST and you want to come up with one on your own? So that's what we'll take a look at in the next couple tutorials. Thanks for watching. Again, make sure to check out the Ideas Lab at ideas.engine.umich.edu. Thanks for watching.